Hey guys, welcome back to the channel after a very uh, tough encounter. We're back again with a new problem. So previously we did this one, which was proved very tough. Let's see if uh, it adds some value while doing this. So next to the next problem. It's a easy problem, guys. So it is lead code 1385. Finding the distance value between two arrays. Okay, we were given two integers, array 1 and array 2. Sorry, integer arrays and the integer d. Okay, return the distance value between the two arrays. Okay, the distance value is defined as the number of elements such that from the first array there is no any element in the second array where the distance is less than or equal to 9. So for example, sorry, d. So for example, 4 minus 10 is 6, d is greater than 2. I mean, d is greater than 2. Sorry, 6 is greater than 2. And same for the 9, for the 1, for the 8 as well. And so we have to return to what is 2. So we have only two elements that are less than what do you call it, less than d. So remaining all are, sorry, we got three elements, guys. 8 minus 9, 8 minus 10, and 8 minus 8. The distance, okay, this one less than or equal to 9. Sorry, okay, we have this. Okay, so we encountered it in 2 at the index 2, so we have returned it. Let's see for the next one. The output seems 2 again, because minus 1 is, I mean, here the distance is 5, 4, 5 again, 9, 19, 30, d is 3. So 4, 4, 8, 4 and 3, 7, and 6 minus 4 is 2, which is less than the value, so we have returned it. Wait a minute. 0, 1, 2. Okay, we have returned the index of array 2 from array 1 given two integers. Okay, return the distance value between the two arrays. Distance value, the distance value is return the distance value is defined as the number of elements of the first element such that there is not any element okay. Not any element where less than or okay. 6 minus 4 will be 2. Wait a minute, let's try to understand the question. We are given two integer arrays and the integer d, return the distance value between the two arrays. The distance value is defined as the number of elements from the first array such that there is no element from the second array where the distance between them is less than or equal to 9, I mean D. If you take 4, so first element is fine, second element is fine, it happened at third element, so we're stopping it here and we return 2. And for this, let's take 1. So for 1 and 4, 5, 4, 5, so this is going fine with 1. And for 4 it's not going well. For 2, now 6, 5, and we got 4 here, and it will increase from here on. And for 3, here we got 6 minus 3 is 3, so we have 1 comma 2 as valid options, and here the distance is 6, so 2 and 2 here is 4, which is less than D, so we eliminate 2, and 1 minus 2 of minus 2 is 3, which is less than D. Well, for 100 the distance seems very clearly greater than 6, and for 3, 3 and 2 will give 5, which is 6. So let's do one thing, let's sort both of them. 1 dot, so we have sorted it. We have to observe the pattern. We are going through each element from the first array. So we have problem with 4 and 3 here, 1 and 2 are fine, and from here we have problem with 1, 2 and 3, 100 is fine, and from here we have no problem with 4 and 5. So seems like it's better if we are uh, traversing from backwards. So let's do one thing, let's keep I equals to is greater than 0. So wait a minute, seems like there is a trick here. Let's do one thing. Since we have sorted it, let's do the brute approach first. Then let's proceed to the optimal one. Sorry. Also, let's see the constants. The length of array 1 and array 2 will be between 1 and 500, and the values elements will be between -10 and 1000, and d will be 0, between 0 and 100. So for the absolute of and let's keep answer equals to length of array 1. So let's go. Sorry, it's it seems like it's working fine. Let's add few cases. I'll just leave it like this. You don't even need to do the sorting here. It will go fine. Okay, let's submit and see if it accepts. Well, it does accept, but it's not the optimal solution. So let's try to make an optimal solution. So let's see the topics first. The topics includes array, 2 pointers, binary search, and sorting. Array, 2 pointers, binary search, and sorting. So we sorted the array. Okay. I think if we take the central element, what will it be? 1 8 plus 10. If you take 9 and 10, 4 minus 9 and 4 minus 8 minus 4 will give 4 and 5, which is greater than 2. So they are not densely packed. And for this, the sorted order will be minus 3, minus 4, 6, 10, 20, and 30. Sorry, it is already in sorted order. And the middle element for 1 will be uh, we can do binary search here. So minus 3 minus 1 will be 4. Let's do binary search here. Let's implement binary search. It's high time we have to learn about binary search. Binary search. We did learn about binary search previously, but we didn't master it properly. So let's see. Minus 4 by 2 will give minus 2, which will be the pointer forward. And 30 plus center and right equals to less than or if So, a center if the center value is less than the value, then we shall keep L equals to C plus 1 or equals to C. C equals to R plus L by 2. Let's see the binary search. Binary search of, you have to find in second array and the value is I and the size is length of, wait a minute, you don't need size here. Let's see what happens. We got 2 for 1, 0, 1, 2, 6 minus 1 is 5, 3 minus 1 is okay, 4 for 2. Let's see, okay, let's check this one out. So sorry. For 4, 5 and 8, we first check 4, which is close to 1. Okay, 5 is close to 8 actually, but we got 5. Wait a minute. For 4, month index is 8. Let's check this test case. Let's go 4, 5. Okay, let's see 4, 5. So for 4 we got 1. 1 will be, okay, go. I understood what's happening wrong here. Now let's see error of x as well. Syntax error, guys. Let's see. So for 4 we found 4. For 5 find 4. Sorry, we found 5. And for 8 we have, like, we found 8. And here let's now do one thing. We got the index right, so we have to check the if if it's not equal to I, and how if x minus 1 is greater than 0. Array of x minus 1. So let's see if it is working fine. If it is working fine, let's discuss the intuition. Oh, sorry. Right, guys. So let's try submitting it. And if it is working fine, let's discuss the intuition. So, guys, what's happening here is instead of searching for every element in the array, uh, we are doing binary search here. So, binary search will give, for example, let's take an example. So, from here, if it is in the sorted order, it will be 1, 4, 5, 8, 9, 10. And if the element exists, if the element 4 exists, then it will give the index of the 4. or else it will give the neighboring elements, either the smaller one or the greater one. So for 4 and 4, now it will check the distance between the neighboring elements and the searched element. So here we are checking the current element. If it is uh, equals to, if we find the same value, like since it is 4, we found 4 here. 4 minus 4 will be 0. So this will be, this won't happen. And for 5 we find 5. 5 minus 5 is 0. It will give continue. And for 8 we got 8. 8 minus 8 is also 0. It will continue. If we didn't find 4, it will give the nearest neighbors like 1 and 8. So if the element is, not found, it will give uh, the greatest neighbor of 4, which is 8 here, and the least neighbor of 4 is 1. So we are checking between 1 and 8. If the difference is less than 4, I mean difference is less than d here is 2. 8 minus 4 is 4, and 4 minus 1 is 2. So the difference, if there is a, if the distance is less than 2, then it will continue here, and the search and the search operation continues, thereby going through every element and finding the optimal one. It seems like our option is better, and the time complexity here is, for binary search it will take log n time, and for this for loop it will take order of n. So if the length of array 1 is order of n, length of array is n, and length of array 2 is k, then the time complexity here will be n log k. Let's ask ChatGPT if it can be optimized. Before that, let's see the optimal answer here. Okay, thing is happening here. So bisect right, bisect left. I think it is the bisect is the binary search, I guess. Let's ask ChatGPT. So let's ask if it can be, can it be optimized. All done a nice job with binary search. Let's break this down carefully. Your current approach is sorted both arrays. Okay, so the time complexity is not okay. It's fine. You sort both arrays, n log n plus m log n, for each element in array 1, n times you binary search in array 2. So order of log m. Inside the loop, you check array 2 of x and array 2 of x minus 1 for closeness. So overall, order of n log m plus n log n plus m log m. That's already efficient. So your binary search function is not a standard bisect left or bisect right. It returns some index near the value but requires manual x minus 1 checks. This works but can misbehave on edge cases if you are not careful. It's time we have to learn about bisect, guys. I never used bisect before, so I'll get back to you when I learn bisect. So for now, we implemented an optimal solution, and the approach goes like this. For binary search, we are checking the middle element, I mean the element that matches our value, and we directly go to the middle one, and if the middle element is greater than the value, if the middle element is greater than the value, then we won't find value to its right because it is sorted. We have to check the left part of the array. So we moved R to the center, which is the greatest, I mean greater than value, and L we move to the, and if we find the element lesser than the value, then we won't find it to the left, so we move to C plus 1th position since he is already lesser than value. Or if the element is equal, then it will return C. If it is not equal, it will break the loop and return C. So that is the binary search, and here we are searching, we are doing the binary search. If I exists in the array 2, then the distance will be 0, and according to the constraints, the distance can be between 0 and 100, and if I find 0, then that means it's screwed for sure. So 0 will always be lesser than or equal to D. It will continues if both are same. If we didn't find the maximum element, sorry, if we didn't find the exact element, then it will return the maximum element for X, and we remove the maximum, I mean maximum neighbor of I, and the distance is fine with it. Then we are checking the minimum value of the minimum neighbor of I, and if it is also good, then we are incrementing the answer. If not, it will continue. To make it even more sharper, we can do this. If one of the condition proved to be true, then it's done. So that's it. I hope you guys understood the intuition and loved the content. uh, if you like the video, upvote it. If you find it useful, and share it with your community. And that's it, guys. Keep pushing hard, and goodbye. Let's meet again with another video.